If somebody can let me know when I'm 15 minutes from the hour and 15, that would be really good. Thank you very much, everybody, for being here. It's absolutely excellent to see so many of you. Were any of you here in Llangollen when I did a sacred geometry talk? Well done, brave lady. Thank you very much for coming back. Today's talk's going to be a little bit different, partly because I wanted to do something slightly different, having spoken here sort of, 8 weeks or so ago, and partly because due to the profound amount of sunlight we've got, we can't actually use the projector at the moment. So I'm having to go back to using an old technique which I had before I had a laptop, which is pictures like this. Hopefully you'll be able to see them all. I can either hand them round or people can come and look at them later. There's a bit of a density warning on this talk. This could easily you could easily spend a term doing the work we're going to do in the next hour and 15 minutes. So there will be a tendency every 10 or 15 minutes, probably even shorter, for your consciousness to wander off. That's absolutely fine by me. Probably do it myself. We're not used to this amount of information. By and large, we have about a 15-minute attention span, and then you expect some adverts or to go and get the kettle. I like to pack as much stuff as I can into my hour and 15 minutes. So are we all sitting comfortably? Yes. We'll begin. The shapes we're going to look at today are all examples of growth and reflection. Basically, through simplicity, we move from simplicity to complexity in really beautiful concepts. These concepts are the very basis of the physical sciences that are now looking at our world. Biology, physics, chemistry, and looking at the world in terms of geometry, the geometries we're going to be looking at today. We're each made up of billions of centres of vibrating energy, as is absolutely everything around us. And we exist in a field which is made up of lines of vibrating force which guide the little balls of energy that make us up. From the tiniest quantum event through all of biology to galaxies and the hearts of stars, the shapes are the same. These are the shapes that make the house that consciousness built, the one that we live in. There's going to be no sums, there's only going to be shapes and images, and hopefully some quite satisfying nuggets of philosophy as well, because geometry is a way of looking at the entire cosmos and making it look comprehensible. As such, it's very easy for me to wander off in one of these talks, and I'm going to have to really concentrate hard to try and stay on beam for the hour. Thank you very much. The other thing is that your biological system is already in full cognizance of all the shapes I'm going to show you. Inside the human biosystem is all the data necessary for reconstructing the cosmos. That means that inside you, there's resonant vibrational counterparts of these shapes, which are just looking for their counterparts to sing in resonance to. So as some of these shapes are shown, you will certainly feel your inner you sing. So the information's not important, it's the shapes. So what is sacred geometry? I think a lot of people are scared off by the word sacred, which is understandable. It's a difficult word to define. My favourite definition of it is that which does not change over time. Now, the information we're going to be looking at today was first written down 350 years before Christ by a Greek, I think, called Euclid. It was actually known, all of this information was known to the Babylonians and the Sumerians before them, 4,000 years BC. It was known in the Stone Age, in the Neolithic. There were Stone Age people, we haven't got a picture of it, carving some of the shapes we're going to see today 5,000 years before Christ. This is very old knowledge. It hasn't changed in all that time. We've discovered many more things about it. We've discovered many more things about how applicable it is, but it has not changed. Most other data you're going to stumble across will change tomorrow. So that's sacred. It's at the heart. It hasn't changed. It's been at the heart of our culture and our knowledge for thousands and thousands of years. It's also at the foundation of all natural design. Ferns and plants and animals, where leaves turn up on a plant stem, how your finger joints relate to your arm joints. Absolutely everywhere this geometry prevails, and that includes your immune system. Your immune system was originally designed to deal with invasions from other planets, stuff that had never been seen before on planet Earth, and it does that by being geometric in basis. Whatever it is that's invading will have a geometric base, which means it can be recognised and countermanded. So it's at the heart of your very physical system and at the heart of every system that we know, every living biological system. And for all its complexity, nearly all of it can be done with a ruler and a pair of compasses. And one of the things I recommend people really do is get hold of a book somewhere that really fires them up on geometry and try doing some. Look at a crop circle and try and copy it onto a piece of paper. Try and find out how it works, because you'll be exploring your very inner structure by doing that, and your inner structure will recognise what you're doing. So it's right at the heart of your being. You can do it with no numbers, no sums, ruler and a pair of compasses if you're inside with a piece of paper, or a rope and a peg and a piece of spray paint or what have you if you're doing landscaping outside. It makes landscaping really easy. Most of all, of course, these geometries have been used in all sacred spaces, from barrow to stone circle to church. They're still even used even today. In these ages of ignorance, I think some of these geometries are still manifesting themselves in sacred buildings. As far as number is the matter of mind, and number is something we're just not going to deal with at all today, thank you very much. That is to do with mind and the spirit and the design of things. But the way it expresses itself in space is the business of geometry. Geometry is the way number unfolds into space, and sacred geometry is the geometry which bonds everything from the atoms in your body to the galaxies that we can see so far away. We start off with a very simple example here. We're going to see a little bit more about triangles later, but can everybody see this? Is that all right with the camera? Very good. This is a very simple design. It's called a cock snowflake. And what you can see is a giant pink triangle in the middle, surrounded by green triangles, surrounded by orange, then yellow, then pink again. Now you can see that I could fit 4 of the green triangles into the pink triangle. What's it called again? A cock snowflake, K-O-C-H. Oh. Yeah. So effectively each triangle is half the dimensions, i.e. half the length of the triangle it sits by, and about a quarter the area. So you can fit 4 of one into the next layer up. So I could fit 4 green into the pink, 4 orange into the green, 4 yellow into the orange, 4 pink into the yellow. This is just with a 3-sided figure. We can already see how beautiful reflection, self-similarity and growth can be. And one of the very interesting things about this is if you look carefully, you'll see the triangles are staying inside a straight line. We could effectively draw a triangle around this pattern, and if we had an infinitely sharp pair of scissors, we could continue to add smaller and smaller triangles to the outside of this design. There's computer programs that do it now, without it ever stepping beyond this boundary. Each triangle would be smaller. So effectively it would be growing forever. Its surface area increases for every triangle you add, but it never outgrows the boundaries in which it sits.
So what's the boundary?
The boundary is, if you look here, there's the first pink triangle, and then the orange triangle, and then the pink triangle is all in a line. Even though we've added these triangles afterwards, they're going no further than the boundary of the first pink triangle. And you could actually draw a big triangle round it, or better still a circle, and it would stay within the boundary of the circle, okay? So the idea is, this is an important idea, because in anywhere other than the 3rd dimension, you don't have to sacrifice other things' space in order to grow. The whole point of people having babies and stuff is not to take up space, they're making space. You're making galaxies and ecosystems every time you do that. Now the other interesting thing about this shape is it could grow permanently without, so the surface area could increase and increase and it would never exceed the boundary of a circle or a triangle painted round it. You can also use the same triangles for it to grow inwards, so that you can use an orange triangle into green inside the pink, orange inside the green. And again, we could add ever smaller triangles into the middle of that. So that's an idea of how very simple geometries can really build very beautiful forms. You see, this is just a plane. It exists in 2 dimensions only. It's flat. But doesn't it look beautiful? It looks even more lovely under ultraviolet light. That's a really zappy design. Now, I'm just going to try and... It will be, yes. We're just going to move that way. I want to have a little bit of a look at a more complicated idea of the same design, and those are called fractals. This is an example of a sort of fractal design. What it is this is actually a slice through a 7th dimensional hypercube. I know that because I know the artist. When you look at it, if you come and look at it afterwards, you maybe see it from where you are. As you concentrate on it, you will see that there's loads of different cubes in it, and some of them are sort of spherical and seven-sided, and your mind is desperately trying to turn this into a three-dimensional picture. Okay, even though it's on a two-dimensional space, you can't help yourself. When you look at my logo at the back, you'll see a seven-pointed star which does the same trick. It looks really flat until you stare at it, and then it starts writhing in front of your eyes. So these actually are normally made up of just two diamond shapes. This one's made up of three, but you have three different diamond shapes. They're all in sacred proportion to each other, though they share a length of side. And what you get when you put them together is this kind of chaotic symmetry. If you look in the middle of this, it's symmetrical. If you then allow your eyes to move slowly outwards in rings, you'll see it's symmetrical all the way to the edge, even though you don't spot that to start with. So that's your mind looking at a flat thing and playing three-dimensional tricks. Even more complicated than those, which are called Penrose shapes, if anybody wants to Google them, are fractals that are made out of simple arithmetic equations. These are tiny little equations which I'm not going to go into, but they only contain 3 or 4 terms on either side of the equals sign. And when you press the go button on a computer, this is what unfolds. They apply a number to a colour to each of the numbers that appears in the infinite succession of numbers that answers the calculation. And what turns up is a picture that looks like this. This one's called a Mandelbrot set. And basically, as you look at it, you can see loads of tridents, like trident shapes. And no matter how far in you zoom in or zoom out, you would just see more and more tridents. Each of them very like each other, but actually completely unique. Now, until we got computers, we couldn't see this sort of thing happening. But the most amazing thing is, has anybody seen those Romanesco cauliflowers? Yeah. It's a fractal cauliflower. All cauliflowers are like it, but they're not as symmetrical as that. That's a really, really shining example where tiny little bits of the cauliflower look like the bits that the tiny bits sit in, which looks like the bigger bit, which look like the whole cauliflower. And it looks like one of these wrapped around a vegetable. It's absolutely outrageous. So we've gone from not being able to see them at all, to be able to see them in 2D and in glowing colour on the computer, to being able to grow them in the shape of a vegetable. Well, that's got to be progress. So those are fractals. As we look at the kind of consciousness and the way things present themselves, there's methods of looking at the third dimension that are really odd. It's said that you can only actually see a dimension from the dimension above it. So if you were living a two-dimensional creature living on the surface of a lake, say, as three-dimensional critters, we find this really hard to imagine because we know everything's got depth, we know everything's got an inside and an outside, but that's because we live in the third dimension. To these 2D creatures, you imagine them just living not even a micron thick on the water, and somebody comes up, and they roll up their trouser leg, and they shove it into this lake so that their foot goes down to the mud at the bottom, and above them is the body in the sunlight. Now, the two-dimensional creatures would have no knowledge of the foot in the mud, they'd have no knowledge of the body above. All they'd be able to see is a circle opening in their own presence as this kind of thing turned up. I've normally got a couple of slides that show you how these things work. We can't do that at the moment. But you could only see that flat world from above it, from the third dimension where we are. And the fact that we can see the third dimension suggests that we're actually fourth dimensional entities, if you have to be one dimension above where you're looking.